Thank you very much. So Piksel, for those who don't know, we're a specialist in online video solutions. We've been providing OTT, VOD services for broadcasters, telcos, pay TV platforms for over 15 years. And about 4 years ago, we made a big bet from an R&D point of view, and we decided to build a whole new video platform for native for the cloud. That platform, the Piksel palette, is built on microservices. So I could talk about this for a long time, but I've got about 7 minutes, so I'm going to be really brief. And this is the brief. So the brief, using microservice cloud to earn money from VOD services sooner. So this is about earning money, earnings. That's about more revenue, lower costs, and it's about earning money sooner. So this is about speed. So I'm going to talk briefly about how we use microservices to get revenue quicker by delivering and making content accessible and discoverable. I'm going to talk about microservices, how we use them to lower infrastructure costs. Microservices allow us to innovate faster in the marketplace. And finally, I'm also going to talk about microservices in terms of how we can use them potentially to sweat our existing legacy assets, to make your investments last a little bit longer. So let's have a quick recap. As I'm the first person, what are microservices? So as a comparison, let's think about our non-microservice approach. Let's think about our monolithic approach. This is where effectively we support many operational functions, all in one code base. Or maybe your workflows are built up of a number of different monolithic systems. So talking about VOD today, that could be your ingest, your encoding, packaging, maybe your offer management, entitlement, authentication. All of these could sit potentially within one or a small number of monolithic applications. Maybe you've got that on-premise, maybe you virtualized it, maybe you're in the cloud already. Microservices, by comparison, this is a different architectural approach. Software is decomposed into smaller components or services, and each one is individually deployable. Ideally, each microservice really only does one thing, or at least does a very small thing. There's quite a conversation about how big is micro, but that's for another day. So we can take these microservices and basically we can build up what previously was a monolithic application by bolting functions together from a number of services. That could be part of a monolithic solution, the whole thing, or even your entire digital supply chain. For us, this is really what a microservice looks like from Piksel's point of view. I'm not going to go deep into technology today. My colleagues may do here. But just so you're aware, our microservices, our platform is based on clusters of containers. We utilize Docker, Mesos, and Marathon for that. And we host these in the cloud, but we are cloud platform agnostic, and if you really want to, we will put them on premise, but you lose a lot of the benefits. So let's go back to that revenue question that we started with. One of the key things we can do is to make content available and make it discoverable more quickly. If it's not, you really can't drive any revenue. So if you're running a catch-up service, it's no good if people can't catch up. If you've got an AVOD business, you're running an ad impressions, they need to be able to view that content quickly. If you've got TVOD, it's all about getting your store purchases. And even SVOD, it's about keeping customers happy with the content so that they don't churn. So if we just think about this from a metadata point of view for a minute, we get metadata come in with new content. Causes a workflow to be kicked off. So we have a workflow microprocesses, and they themselves then kick off worker processes. Those worker processes for us do things like matching programs, normalizing content, and enriching. And then we have typically publication processes as well that actually deliver that metadata out. This workflow for us is highly automated. It's about low latency, and it's about minimal effort. It's about taking the world of kind of moving bits of paper around out. So that's kind of easy. But what happens if actually we're not just getting the odd show turn up, we're getting an enormous catalog drop on us? How do we deal with that? So some of our customers, they get metadata drop through for content coming through of gigs and gigs and gigs. Their old way, it would take them hours and hours to process. So again, we kick off a workflow, but this time we need to process it. So we spin up more and more and more worker processes to get through that content. This is individual microservices, individually scalable. We go through publication, and of course we spin down those processes again afterwards. We don't need them after they've done their job. Now, we scale at sub 10 seconds, so we can realistically scale fast enough to deal with this. But other customers we have also deal with lots of endpoints. So we've got customers in the US particularly, they're dealing with distribution to hundreds of endpoints. They need to get the content out, distribute their content and their metadata to hundreds of endpoints. Actually, so in this case, we can scale up the publication processes as well. So we just scale up publication processes, deliver to those hundreds of endpoints, and scale them down again as well. Come on, clicker. What I'm talking about here is a metadata workflow, but actually what we're talking about really is generic workflows being managed. This could equally apply to your video content. So actually, if your rights guys do a deal to sell your catalog of 20,000 titles, and the distributor wants to know when they're going to get it, well, you can tell them fairly quickly because you're not relying on hardware, you're not relying on fixed throughput infrastructure on premise. You can scale up those processes to deal with the processing you need, so it gives you very predictable costs and very predictable throughput. The other thing we're doing, obviously, is we're only spinning up resources when we need them. So actually, our operational costs needn't be scaled up for our peak. They're scaled up as we require them. So really what that means is, so if the blue line is our demand peak, and the green is effectively how much infrastructure we've got spun up at any one time, that because we're spinning up microservices very fast, spinning them down very fast because they're very, very granular, we can hug the usage curve more closely. The closer we can hug the usage curve, the less wastage there is. Less wastage, less cost. That's all great, but actually I think the real win with using microservices is about innovation, is about speed of innovation. So obviously one way to reduce your time to revenue, reduce your cost is to innovate faster than your competitors. So microservices really help. They also make it less risky. So if this is what a complex system might look like. Think back to our monolithic solution. So it's a complex system. Release effort is fairly high. We've got a lot of testing to do, a lot of regression testing every time we do changes. So there's an optimal point where we want to release. Any lower down, we don't get benefit. Any higher up, it's more effort. So that's the sweet spot. But of course, the sweet spot there is actually an awful lot of features we've added. We've made a lot of changes. It's what we call a big bang release. So we've taken a monolithic application. We've had to make lots of changes to justify the release. It means we're delivering a complex system with lots of changes. It's very high risk. What we really want to do is make that release effort much, much lower. So with microservices, because we're deploying individual services, very small, much simpler systems, we reduce the release effort. We use automated pipelines. We use automated testing. And that means that we can release more frequently, and we can do so at lower risk. To give you an idea, rather than software releases quarterly or monthly, we typically release about 10 to 20 times a day directly into production. Now, the final point really is about how we can use microservices to extract value from legacy. So we've talked a lot about quite big changes, but clearly any change has cost to it. There's the cost of actually, besides the cost of buying new systems, licenses, actually there's a cost of change, there's a cost of selection, there's a cost of project management there. If you can keep your existing systems going longer, then that's a cost that you can avoid. So microservices are a really good way of doing that. In fact, microservices are really strong because of the fact that they can allow you to make these small changes to your system. They give you the flexibility that actually changing your end-to-end, swapping one system out to the other doesn't. So they really act a fantastic way. You can use them as point solutions or stepping stones to migration. So classic thing is to look at your existing monolithic applications that you've got and realize you have a pain point. Now, you could replace the whole thing because of that pain point, or you could look to start saying, okay, well, I'm going to bring in some new services just to deal with that particular pain point. You could also say, well, our systems aren't good enough anymore. Everyone's overtaking us. So you can think about microservices as a way to bring in innovation. So bring in new features with microservices. And then the obvious step then is to say, well, actually, those monolithic applications really are reaching end of life. So we want to start adding microservices to replace them. But we can replace them gradually. So over time, until eventually we've subsumed all that functionality into a new set of microservices. And this is a very safe way of doing it from a business continuity point of view, that simply kind of lift and shift and big changes don't deliver. And that is nearly 10 minutes. Thank you.
Thank you very much, Clive. Does anybody have any questions? You'll get a chance to ask a question after each panel, after each talk, and in the panels as well. No? Come on, you've had coffee, right? All right, yes. Please just say your name and your company.
Ian Parr from BT. I was going to ask, you mentioned that I think you've said you were cloud native, public cloud native for your application. Do you get a bigger bang for your buck from going public cloud in terms of the utility and the innovation, or from the microservices architecture?
Do we get a bigger bang from
in terms of the agility that you mentioned that you get from your microservices architecture and the ability to innovate? Did you get an equal shot in the arm and that pace of innovation from adopting a public cloud approach?
The main change is the innovation comes from microservices, but clearly you need to be deploying that within a cloud, a cloud platform. So I mentioned we will deploy onto on-premise if people want, but actually it's a cloud-based architecture that gives you the benefits there, and so. It needs to see those benefits. It needs to be a cloud-based architecture. It doesn't necessarily need to be public cloud, but it does need to be cloud-based.
Okay, great. Any other questions?
Hi, I'm Ben Schwartz. When you talk about microservices, I was a software developer in the 90s when object-oriented development came along, and it was going to be fantastic and save a lot of time and stuff. But it worked out at the end of the day that it was quite a lot more expensive to develop. Are you seeing that with microservices? I mean, if you have a specific task to say, and forget about microservices, it's going to cost you 100 days of work to do it. Now you're going to do a really clean microservice-based thing. Is it going to cost you any more, that single development?
I think actually, so I guess the difference between perhaps traditional object-oriented and now is that clearly object-oriented could still be within the same code base, and so some of the regression things were still there. With object-oriented, with microservices, now we're seeing much faster development because of effectively because of that separation of concerns. So we are seeing much faster development, You move guess, some of the complexity you move into testing. So actually, I suppose there's a cultural change between perhaps a traditional testing approach. You need to start thinking much more about test automation instead. So there's differences in terms of perhaps what the skill sets of your teams. But no, we're seeing much faster development, which usually equates to much cheaper development than a traditional monolithic approach, be it object-oriented or otherwise.
That's great. I think that's all we're going to have time for. That's a really great introduction to microservices. Thank you very much, Clive.